Okay, the question is this question. This is question number 3. Okay. Okay, so we read first the question. Okay. Two capacitors, C1 equals to 6 microfarad, and then C2, okay, 3 microfarad, are connected to series with a 10 volt battery. So the capacitors are then disconnected from the battery. Okay, here for the second diagram, then connected together as shown here. So we are going to determine the final charge on each capacitor. So the capacitor 1, 6 microfarad, label here, so easier for you to see. Then this is 3 microfarad. So we are going to determine the final charge. So as the capacitor here is connected to the battery, so that means it is the charging process. So we are going to determine the final charge, means after it is fully charged. Okay, so for fully charged, the voltage of potential difference used must be 10 volt lah. Fully charged mean the voltage across them each is 10 volt. Means the charge flow from this 10 volts, so the voltage is 10. So the capacitance will be the total capacitance. So we can calculate the final charge Q using Q equals to CB. Okay. So the the C capacitance is the total capacitance. Okay. So the capacitance arranged in series. So we use the formula for capacitance is 1 per C because they are arranged in series. So 1 per C. So we calculate the voltage first. We substitute the voltage here 10 for fully charged, final charge. So the CT is use 1 per C. Okay, so we substitute 1 per 6 microcoulomb and plus 1 per 3 microcoulomb. So no need to convert the unit because final answer also in micro. So the total capacitance is 2 microfarad. So you substitute here 2 microfarad. So no need to convert the unit because the final answer for Q also will be micro. Okay, so 10 times 2 will be 20. So it's in microcoulomb. Because you didn't convert the unit just now to farad. So the final answer for charge also got micro. Okay, so this is the final charge on each capacitor. So the charge accumulate, the final charge here will be 20 microcoulomb. For C2 also 20 microcoulomb. Okay, next. The next question is, okay, got some more. So now for diagram 2, we are going to calculate the final charge also. So the capacitor now disconnected from the battery. So that's mean no longer battery here. Okay, no longer battery here. So this is 6 microfarad, this is 3 microfarad. So this capacitor, okay, these two capacitors, the equivalent capacitors can be drawn also like this. Okay, it's the same because this is in series. Imagine this is one path. So you can put the C1 and C2 anywhere. Okay, so you can put like this. So this is the equivalent circuit. Okay, can you understand or not? If got problem, you can write down in the chat. Chat here. Okay, so this is the equivalent circuit. So if you see the second one, the second equivalent circuit, you can see clearly that the capacitance are arranged in parallel. Okay, so to find the total capacitance, you can use the C1 plus C2. Okay, so for total charge formula, we use Q equals to CV. So the capacitance we can calculate using parallel formula C1 plus C2. So that's mean the charge will be 20 plus 20 because it cannot run away. Okay, from the circuit here. So the total charge here is the same as the initial here, the from one. Okay, from one is 20 each, 20 each. So that's mean the total will be 20 plus 20. Okay, C1 has 20 microcoulomb charge, C2 has 20 microcoulomb charge. And then why it is plus because it is arranged with terminal. Okay, you see the terminal here, and you look at the terminal of the capacitance. Okay, if this is the terminal positive of the battery, so this side of the capacitance one will be positive, the other side negative. Then C2 also the same, because the terminal positive of the battery is on this side. So will be positive, negative, positive, negative. So that's mean the label here KL, MN, here also same KL, but this one is NM. So check. So that's mean MN positive, negative, MN positive, negative. Here M, this is M. Okay, can see or not? M, M. So that's mean here positive, here negative, here is negative, here is positive. So when you put this on other point like this, so the terminal will be like this, positive, negative, positive, negative. So therefore, the total capacitance, the charge can flow freely in the circuit here, so it will join together here, positive. So if you complete this circuit, you will get that the charge flow out together. So that's why you total the charge 20 plus 20. Okay, this is total charge, and then the capacitance. The capacitor is arranged in parallel. So the capacitance you calculate as 6 plus 3. Okay, so 9. Okay, parallel here. Okay, so you substitute into here 9. So you can get the voltage across them because they are arranged in parallel. Okay, so the voltage because the charge now can freely move here in the circuit, so the voltage now decrease. Okay, decrease. So if you think the logic, the value here should be the value of the potential difference will be less. The voltage across each capacitance, because the charge flow out already. It can move freely. That's the logic. So you cannot use this V 10 volt. Okay, if you don't understand, can write there in the chat for check box there. Okay, so now we calculate the V. Okay, 20 plus 20 is 40. 40 divided by 9, so you get 4.444 volt. Because we haven't come to final answer yet, so I write in the larger significant numbers of significant feature. Okay, now after you got voltage, so that means the voltage across C1 and C2 is the same. Okay, so we can calculate the individual charge on each capacitance. So the total charge must be the same, 40. So we can check there, check later. So for capacitance 1, it has charge C1 times V. Okay, so C1 is 6 microfarad. And then the voltage we calculate just now, 4.44 volt. So you get to 26.7 microcoulomb. Okay, next for capacitance 2, it has charge C2 times V. Okay, so C2 is 3 microfarad, and the voltage across is 4.444 volt. So you get 13.3 microcoulomb. Make sure the total here is also 40. Remember I said just now, this is closed circuit, so the charge cannot run anywhere. It still has the total of 40 microcoulomb. So this is the answer, the individual charge. The final charge on each capacitor. This is what the question was. Q1 means the capacitance 1 has charge 26.7 microcoulomb. Q2, the capacitance 2 has charge on it 13.3 microcoulomb. Okay. So that's the answer. Okay, now for question 3.2. This is 3.1, 3.1. So 3.2, okay, 3.2, they changed here KLMN, and then the initial charging also is different. They put it as parallel, okay? Arrange the capacitance parallelly. Okay, so we need to calculate the charge, the charge accumulate on C2 and C1 first. Okay, so we calculate total capacitance first, or effective capacitance. Okay, C2 has 6 microfarad, C1 has 3 microfarad. So to calculate the total charge, okay, we need to calculate the effective capacitance first, or total capacitance. So they are arranged in parallel. So that means the charge, the capacitance here will be 6 plus 3. Okay, 6 plus 3. The voltage is 10. So 6 plus 3 here at 9. Okay, so the total charge is 90 microcoulomb. Imagine the charge can flow here, then split into 2. Then at this point, they combine. Becomes 90, back to 90 microcoulomb. Okay. So this 90 microcoulomb charge, now the 10 volt is disconnected. Okay, disconnected. Okay, then the capacitance becomes like this, but they are arranged, okay, K, L, here, M, N. Okay, now the individual charge here has different, in capacitor, each capacitor has different charge. Before they are connected, they have different charge here because the charges split into 2. Okay, I repeat, the charge flow here split into 2. So each of the capacitor will have different charge. So we calculate first the charge Q2 and on Q1. Okay, Q2 is 6 times 10. So you get 60 microcoulomb. Q1 3 times 10, 30 microcoulomb. So if you total this up, you still get 90 microcoulomb charge. Okay, now we go to the next after the battery is disconnected. Okay, so the question 1, final charge. So this final charge on each capacitor now is no longer 60 and no longer 30. Okay, no longer 60 and no longer 30 each capacitor, because it can move freely in the circuit here. Okay, so this is not the answer. Okay, so you need to calculate for the voltage first across them, and then the total capacitance, and then we can calculate the individual total charge first, then we can calculate the individual charge. Okay, so the equivalent still the same. This is the one path. You can see here, this is one path, one closed circuit. So if you put, or if you change the position here along any point on the circuit here, so it doesn't matter. It doesn't matter. The charge still can flow freely along this path. Okay, so therefore you can arrange it like the second circuit here also. The second circuit. So these two circuits are equivalent. But if you refer to the second circuit, you can see clearly that how the two capacitors actually are arranged in parallels. Okay, I repeat, the two capacitors actually are arranged in parallel. So the second equivalent circuit is more clear, okay, clearer to see. It is, they are arranged in parallel. And then look at the label here. It can help you. Okay, so this scale, and this is MN. So M is this side. Okay, still facing the L here, M L, N on the other side. So N with K. So N here is connected to K. Okay? So imagine you connect it using wire in the lab. Okay, so you can connect one wire from terminal N to another wire to terminal K. So it's easier to imagine if you can help you to imagine if you imagine you use the wire in the lab. Okay, understand or not? Any problem? Okay, can write something in the chat box there. So that I don't feel I'm teaching here alone. Okay, feel like not in the class. Okay. Okay, understood. Romy also. Okay, next we go to the next part. So next part, refer to the to get the total charge now. To get the total charge, so we need to check the sign. Because now they are terminally. We check the terminal of the capacitors. Okay, for the initially, before they are disconnected from the battery, okay, the terminal of the C2, okay, check the terminal of the C2. This is terminal of the battery here, terminal positive. So K must be positively charged, so L is negatively charged. Okay, then for C1, okay, terminal of the capacitors for C1. Okay, refer to the terminal of the battery. This is the terminal positive. So M will be positively charged and therefore N will be negatively charged. So the terminal of the capacitor 1, okay, will be like this lah, M positive and negative. Okay, now transfer to here. Okay, K positive, L negative, M positive and negative. Okay, if you transfer here also you can see clearly that it's not the same as before. Okay, the question B1, question question A. So question 3A, okay, it's not the same. The terminal are different now. Okay, terminal are different. Their charge on each charge also different. Okay, so the total charge also will be different. Okay, the total charge, the charge on this circuit, because it is connected, complete circuit here, so the charge can move freely in the circuit here. So therefore, the total charge will be different. Okay, because of the terminal is connected like this. So it's become 60 minus 30. So the total charge is 30. And you cannot add it. So why? Because this is how to imagine why it is not minus. Let's say the charge flow, actually electron flow, right? But charge flow, the flow can, current flow also can. Imagine you can complete the circuit here. So the current, imagine there's a current flow like if you complete the circuit. The capacitor now act as a source of energy. Okay, so the current flow here, and it will attracted to the negative plate here. So flow here, and some will flow out. It depends which is larger. So 60 Q2 is larger. Okay, so 60. So that means 60 minus 30. So if you connect the capacitor like this, and the charge will flow out from this what you call this circuit, okay, only 30, only 30 microcoulomb. Okay, so the total charge is not 90, no longer 90 microcoulomb, but only 30. So that is why the arrangement in the terminal is very important. Okay, so after you get the total charge, okay, it's not 90, it's 30. So be careful, always check the terminal of the capacitor when you want to connect it, without the what call this battery. Okay. Okay, so what we are going to substitute for Q total in this is 30. Okay, in this equivalence, in this total or effective total charge. Total charge 30, total capacitance, okay, total capacitance, the capacitor here arranged in parallel. So you use C1 plus C2, so 6 plus 3. Okay, still the same lah, 6 plus 3, 9. Parallel. Okay, so we can calculate the voltage across the capacitor. So the voltage across the capacitor, 30 divided by 9, so 3.333 volt. Okay, 3.333 volt. Okay, still not finished yet because the questions want final charge on each capacitor. So the final charge on each capacitor is no longer 60 and no longer 30. Because the charge can flow out, can move freely in the circuit here. So, but the voltage remain the same, is 3.333 volt. So you can use Q equals to CV for each of the capacitor with V is constant. Okay, so C2 is 6 microfarad and then V is 3.333 volt. So you get 20.0 microfarad. And then for capacitor 1, capacitor 1, so C1 is 3 and V is still the same. And remember, it's now it arranged in parallel, so voltage is the same, 3.333 volt. So the charge on the capacitor here is 10.0 microcoulomb. Okay, you can check, you get 20 plus 10, 30. So the total charge is 20. Okay, total charge is 20. So it is understood here. Okay, only 30 total of charge. Mainly because of the terminal is arranged like this. Okay, positive, negative, here negative, positive.